Now let's put some things together. We're going to solve systems using matrices and hopefully solve it a little bit quicker. But first, letter A, solve the following system. The easiest way is elimination because the four x's are already lined up. So we just add straight down, those cancel out. We get 6y equals negative 36. Divided by 6, y equals negative 6. Now I can plug it into either one equation. Plug it into the bottom one. 4x plus 8 times negative 6 equals negative 24. That's 4x minus 48 equals negative 24. We add 48 to both sides. Divide by 4, and x equals 6. So 6, negative 6 is our ordered pair of our solution. Now letter B looks kind of weird, but we're just multiplying. Just like we have with all matrices. We got a 3 by 3, and we got a 3 by 1. So our answer is going to be 3 by 1. So when we do that, we multiply across, we're going to get x plus y plus z, 2y plus 5z, and the bottom we have 2x plus 5y minus z. So it just gives us a system of equations, not what they're equal to, but it gives us a system of equations. 3 variables, 3 equations. Okay, we can do that. So actually, that is this problem right here. So let's walk through how to solve this system using matrices. So x plus y plus z equals 6, 2y plus... So now we actually have our answers, what they're equal to. So we can turn them into a matrix. Or a table of numbers first. So we just take away the x's and the y's, and we have a 0 for this x. And then we split them up, and we make the coefficients one matrix, and what they're equal to one matrix. And then we have a third matrix, which is x, y, z, because that's what we're trying to solve for, in that order, because that's the order that we got these. It was x, y, z, so it's got to be x, y, z here. So, we can write this equation. The matrix, the 3 by 3 number matrix times the variable matrix equals our answer matrix. Or in another way, we could say A times X, which is our variable really, equals B. So A is our 3 by 3 matrix, X is our XYZ matrix, and B is our number matrix like stated before. And again, you can see the multiplying, what we did in the warm-up, that's what we got. So we need to get X by itself. Well, really the only way we can do that, we can't divide by A. That's what we would do normally. We divide by A, X equals whatever B divided by A is, and yay, we're done. But that's not the case here. We can't divide matrices. It's not an operation that can be done, that makes sense, that happens. So what we have to do is get rid of that A a different way. And the way we can do that is multiply by the inverse. And since A is on the left side of X, we can't multiply, we don't want A times X times A inverse, because we know order matters, and be X times the A inverse, and that's not what we want. So it's A inverse times A times X equals B. Well, we know that an inverse times itself is just the identity matrix, or basically 1, and the identity times X, or any matrix, is just, oops, forgot to multiply the other side by the inverse of A. So X is just the inverse of A times B. And that's how we can solve this system. Now I'm going to kind of skip ahead of things that we haven't done yet, because we don't, sorry, trying to do too many things at one time. So here, kind of shorthand, x is going to equal A inverse, if this is A, that's x and that's B. So we just do the A inverse of B. Now using our calculator or Desmos, we can find the inverse very quickly, which is what I'm going to do. I'm going to cheat, sorry. But that's what I can do. So it's not nice. 9 over 7. I need more room than that. 9 over 7. Negative 10 over 21. 4 over 21. Negative 2 over 7. 1 over 7. And this is why we're going to use technology to find this one, because this is nasty. And we're going to multiply that by our B matrix. And that will give us our X, Y, and Z. So, we are going to multiply that inverse by this matrix. And we're not going to do it by hand, we'll do it with the calculator. We get 5, 3, and negative 2. And that's in the space of x, y, and z. So our ordered triple for this one would be 5, 3, negative 2, or simply x equals 5, y equals 3, and z equals negative 2. So let's try some more of these. We'll try them with some two-variable equations. A little bit easier. So negative 4, negative 2, 4, and 8. We have our coefficient matrix times our variable matrix. We're going to equal our numerical matrix, or our answers, I suppose. So again, to be able to do this, we're looking at ax equals b. We need to multiply by the inverse of a on the left side for both of them. So x equals the inverse of a times b. Now, quite honestly, the easiest way to do it, use our calculator, so let me show you. If my calculator ever wants to load. And this way you can find inverses, you can multiply quicker. If this ever loads, I can show you how to do that. Don't know if it's going to show. Haha! There we are. So second, x to the negative first, our inverse, will give us our matrix menu. We want to go to edit. And matrix A is just a 2 by 2. So you just type in the dimensions. Then you type in your numbers. Make sure when you do negatives, you do the negative button, not the minus button. Because TI is a pain in the... I mean, they're a little bit difficult. 4 and then 8, so that's matrix A. We can go to edit again, down to matrix B, which is our 2 by 1, not 21. That's crazy. 2 by 1. And that's negative 12 and negative 24. So now we literally just have to type in A to the inverse times B, and we can get what the solution is for these matrices. So to use them, we hit math, second, hit x inverse, sorry, and we do A And if we go over to math, we can do... it's not the easiest way to do it. So we'll raise this to the negative first, which is finding the inverse, times our B matrix. Keep hitting the wrong thing. And we get a solution of 6, 6. Whoop. So this is not quite our answer because it doesn't really say anything. This is our answer as an ordered pair, or x equals 6, y equals negative 6. And then we can continue going on with this same thing. And really they're all kind of set up the same way. We got a times x equals b. A being the 2, 1, 1, and negative 1. The x being x and y. And the b being 19 and 11. Now, what's nice about this one is that, okay, I'm trying to get my calculator to shrink here so we can actually see it. There we go. Once we get our dimensions in, all we have to do is change the numbers. So second matrix, oops, I don't want to use matrix A, I want to change matrix A, so second x inverse, over to edit, 2 by 2 is already set, so we get 2, 1, 1, negative 1, again, don't forget to use the negative button, it'll shout at you if you don't. Then we go to the menu again, we're going to edit number 1, so this is a 2 by 1, 19 to 11, and because we already have it typed in, a to the negative 1 times b, which is the same thing we're going to do here, so that those kind of cancel out. So x equals the inverse of a times b. Since we already typed that out, we just have to go up to it, hit enter on it, and enter again, and now we have our answers. Although I don't remember what they are. 10, negative 1. So our solution is 10, negative 1, or x equals 10, y equals negative 1, depending on what kind of problem we're dealing with. Alright, let's do this 3 by 3 because that's kind of a pain. So we go back to our matrix menu, edit, and we want 3 by 3 instead of our 2 by 2. So again, make sure you type in your negatives. Negative 1, negative 5, negative 1, negative 5, negative 5, 4. Which is probably a little quicker on an actual calculator, and you get quicker as you go through this. 1, because the coefficient of x here is 1, and 5, and negative 1. So that's matrix A. Matrix B is going to be our what they equal, so it's a 3 by 1 now. And we got 2, 19, and negative 20. And again, once we have them entered in, go up to the next thing here, hit enter, and we have it. Again, I did not write it down. Negative 2, negative 3, 3, that's x, y, and z. So we can do an order triple. Or just write x equals -2, y equals -3, and z equals 3. Now we got some word problems. Let's do these real quick. We'll call it a day. Find the value of two numbers whose sum is -24 and difference is -30. Now, you could probably figure that out pretty quickly. But if I want a system to do that, I got two numbers, x and y, don't know what they are. But I know that if I add them, I get -24. And I know that if I subtract them, I get -30. So that means our A matrix is 1, 1, 1, -1. Oops. Our variable matrix, is that on you? There we go. Is x and y and equals -24 and -30. So again, it's ax equals b. We need to multiply by a inverse on the left side of both sides of the equal sign. So these kind of cancel out. Not really. So let's find the inverse of a to the -1 by ourselves. It's only 2 by 2, nothing too crazy. Good review. So we've got to find the determinant first. So it's 1 times -1 minus 1 times 1. So we got -1 minus 1 is -2. It's not too bad. So 1 over -2 times our 2 by 2 matrix, or our switcheroo matrix. -1 and 1 switch places, and the other one turn to negative. So when we find our inverse, this is A inverse, we get 1/2, 1/2, 1/2, and -1/2. And now we can just multiply that by b, our -2, 24, and -30. So again, we can use the calculators. We can multiply that out. That's not too bad, although the fractions are not very nice. So let's see. So let's just put them in here because why not? Oops. Go over to edit. Edit. Now we got a 2 by 2. And we're actually going to put the inverse of A in here because that's what we have. Instead of 1/2, we're going to use 0.5 because it's easier to use than come up with a fraction each time. And -0.25. And then we got to put our matrix B in matrix B. It is a 2 by 1, which is -24, and -30. So instead of doing the inverse, we already found the inverse. So we'll just do A times B. So again, negative 27 and 3. So x equals negative 27, y equals 3, or as an ordered pair, however it makes sense to you. It should be a matrix, not a fraction. We got 2 more to try here. And I think we're going to stop there.